Hello once again, welcome back to Billy and Joy's Classroom. But before we proceed, please do not forget to click the subscribe button and notification bell to be updated for our latest video. For today's lesson, we are going to discuss about geometric series, wherein we're going to find the indicated sum of the finite and infinite geometric sequence. Basically, we define geometric series as the indicated sum of the terms of a geometric sequence. So to find the indicated sum of a geometric sequence, we are going to use different formulas. But then it depends on the value of r that we are going to get. So if you can still remember, in our previous lesson, we identified the value of r by dividing the succeeding term divided by the preceding term. So if r is not equal to 1, we are going to use the formula s sub n is equal to a sub 1 minus a sub n multiplied by r divided by 1 minus r. We use this formula if a sub n, a sub 1, the common ratio r are given. We also use the formula s sub n is equal to a sub 1 multiplied by 1 minus r raised to n divided by 1 minus r if a sub n is not given. If the value of r is equal to 1, we use the formula s sub n is equal to n multiplied by a sub 1. If the value of r is equal to negative 1, if n is even, the value or the sum of the geometric series is equal to 0. If n is odd, the sum of the geometric sequence is equal to a sub 1 or the first term. So s sub n is the sum of the first n term, a sub 1 is the first term, r is the common ratio, n is the number of terms, and a sub n is the last term. Okay, so let's try this example. Find the sum of the first 6 term of the geometric sequence 3, 6, 12, 24, and so on. So we have the given a sub 1 is equal to 3, n is equal to 6, r is equal to 6 over 3 or equal to 2. So if you notice, our common ratio is not equal to 1. So therefore, we are going to use the formula s sub n is equal to a sub 1 quantity 1 minus r raised to n all over 1 minus r. So let us substitute the value. S sub 6 is equal to 3 quantity 1 minus 2 raised to 6 all over 1 minus 2. So first we are going to subtract 1 minus 2 raised to 6 and then 1 minus 2. So we'll have S sub 6 is equal to 3 quantity negative 63 all over negative 1. Then we are going to multiply 3 with negative 63. So we have S sub 6 is equal to negative 189 all over negative 1. So this time we are going to divide negative 189 and negative 1. So we got S sub 6 is equal to 189. So therefore, the sum of the first 6 term of the geometric sequence 3, 6, 12, and 24 and so on is 189. Let's try another one. For example, consider the geometric sequence 2, 6, 18, 54, 162, and so on. What is the sum of the first 5 terms? So we have the given S sub n is equal to S sub 5. A sub 1 is equal to 2. N is equal to 5. R is equal to 6 divided by 2 or equal to 3. and then a sub n is equal to 162. So if you notice, our common ratio is equal to 3, so that is not equal to 1. But the last term was given, or the a sub n. So we are going to use the formula s sub n is equal to a sub 1 minus a sub n multiplied by r all over 1 minus r. So let us substitute the value. We have s sub 5 is equal to 2 minus 162 multiplied by 3 all over 1 minus 3. So first we are going to multiply 162 multiplied by 3, and then after that we are going to subtract the product of 162 and 3 by 2, and then divided by 1 minus 3. So we have 2 minus 486 divided by negative 2. So subtract 2 minus 486, so we have negative 484. And then we are going to divide negative 484 divided by negative 2. So we have the sum of the first 5 term of the geometric sequence 2, 6, 18, 54, and 162. That is 242. Let's try another one. Find the sum of the first 10 term of the geometric sequence. If the first term is 4, the common ratio is negative 2, and the 10th term is negative 512. So the given are a sub 1 is equal to 4, a sub 10 is equal to negative 512, and r is equal to negative 2. So our common ratio is not equal to 1. At the same time, the last term was given. So we are going to use the formula s sub n is equal to a sub 1 minus a sub n multiplied by r divided by 1 minus r. So substitute the value. We have s sub 10 is equal to 4 minus negative 512 multiplied by negative 2 all over 1 minus negative 2. So we have negative 1020 over 3. And then we are going to divide negative 1020 divided by 3. So we have s sub 10 is equal to negative 340. Did you get it? Okay, so now will you please try this? What is the sum of the first 8 terms of the geometric sequence 2, 4, 8, 16? You can pause the video for a while to give yourself a time to solve. Okay, so if your answer is 510, you're right. How about this? Find the sum of the first 6 terms of the geometric sequence 4, 12, 36, 108. Okay, so if your answer is 1456, you're correct. How about this? What is the sum of the first 6 terms of 3, 3, 3, 3, and so on? So if we're going to get the common ratio, 3 divided by 3 is equal to 1. So if r is equal to 1, we have the formula s sub n is equal to n times a sub 1. So in our sequence, we have the given a sub 1 is equal to 3, n is equal to 6. So let us substitute the value. We have s sub 6 is equal to 6 times 3. So multiplying 6 times 3, we have the sum of the first 6 terms of the sequence 3, 3, 3, 3, and so on, that is equal to 18. How about this? What is the sum of the 7th term of 3, negative 3, 3, negative 3, 3, negative 3, and so on? So getting the common ratio, negative 3 divided by 3, our r is equal to negative 1. So if r is equal to negative 1, then our n in our problem is equal to 7, then that is odd. So we have s sub n is equal to a sub 1. So therefore, our s sub n is equal to 3. How about this? What is the sum of the 8 terms of 3, negative 3, 3, negative 3, 3, negative 3, and so on? So r is also equal to negative 1. But then, our n is even. So therefore, if n is even, so our S of n is equal to 0. Will you please try this? What is the sum of the first 15 terms of the geometric sequence negative 4, 4, negative 4, 4, negative 4? If your answer is negative 4, that's right. How about this? Find the sum of the first 24 terms of the geometric sequence 5, negative 5, 5, negative 5, 5, and so on. If your answer is 0, you're right. Okay, so this time we are going to find the sum of infinite geometric sequence. So first we are going to get the common ratio. If r is less than 1 and r is greater than negative 1, we can use the formula s sub infinity is equal to a sub 1 divided by 1 minus r. Consider the infinite geometric sequence 1/3, 1/9, 127, 181, and so on. So first, we're going to identify what is the value of our common ratio by dividing a sub 2 divided by a sub 1 or 1/9 divided by 1/3. So we are going to divide 1/9 divided by 1/3. So in dividing fraction, first we need to get the reciprocal of the divisor and then proceed to multiplication. So we have 1/9 times 3 over 1. So let us now multiply the numerator 1 times 3 and the denominator 9 times 1. So we have r is equal to 3 over 9. Then if you notice, we can still reduce 3 over 9 to its lowest term by dividing both numerator and denominator by 3. So we have 3 divided by 3, that is 1, and 9 divided by 3 is 3. So we have the value of r, that is 1/3, which is less than 1 and greater than negative 1. So now let us use the formula s sub infinity is equal to a sub 1 over 1 minus r. Substitute the value, we have 1/3 over 1 minus 1/3. So first we're going to subtract 1 minus 1/3. Okay, so we have 1/3 over 3 over 1, or 3 minus 1 over 3. So 3 minus 1, that is 2/3. So we have 1/3 divided by 2/3. And then we're going to divide 1/3 divided by 2/3. So 1 times 3, that is 3, and then 3 times 2, that is 6. So we have the sum of the infinite geometric sequence 3 over 6, but then we can still reduce this 1 to its lowest term by dividing both numerator and denominator by 3. So we have 3 divided by 3, that is 1, and 6 divided by 3, that is 2. So therefore, s sub infinity is equal to 1/2. Let's try another one. Find the sum of an infinite geometric sequence 9, 3, 1, and so on. So we have the given, a sub 1 is equal to 9, r is equal to 3 divided by 9, or equal to 1/3. So since r is less than 1, or r is equal to 1/3, therefore the series has sum. So we can use the formula, s sub infinity is equal to a sub 1 over 1 minus r. So substituting the value, we have s sub infinity is equal to 9 over 1 minus 1/3. So s sub infinity is equal to 9 over 2/3 because we subtract 1 or equal to 3 over 3 minus 1/3. So we have 9 over 2/3. So this time we're going to divide 9 divided by 2/3. So we have s sub infinity is equal to 27 over 2. How about this? Find the sum of an infinite geometric sequence 2, -8, 32, and so on. So we have the given a sub 1 is equal to 2, and then we have the common ratio -8 divided by 2 that is equal to -4. So since r is less than -1, r is -4, therefore the series has no sum. Now, will you please try this? Find the sum to infinity of the sequence 4, 1, 1/4, 1, 6, and so on. You can pause the video for a while to solve for the value. Okay, so if you got 16/3, you're right. Okay, so that's all for today. Thanks for coming. See ya!